Now that we've reviewed the carbon cycle, we know carbon and oxygen isotope ratios are excellent indicators of paleoenvironment and climate. Geoscientists are able to use shifts in these ratios as proxy data for climate change and perturbations in the carbon cycle through geologic time. These proxies can also be used for correlating rock successions from different localities. Carbon comes with 3 isotopes, 12, 13, and 14. You may have heard about carbon-14 being used to date objects as far back as 60,000 years ago. In older rock, the ratio between carbon-12 and carbon-13 isotopes provides insight into the carbon cycle. When there is a large amount of organic material in the ocean, such as phytoplankton blooms, the seawater will become enriched in carbon-13 because phytoplankton preferentially consumes carbon-12 through photosynthesis. This causes the amount of carbon-13 in carbonate shells and skeletons formed by marine organisms during this time to increase. Using laboratory techniques, we can measure the carbon-13 to carbon-12 ratio in ancient rocks and shells to identify events that caused a shift in the ocean's productivity by microorganisms. For instance, the variation in carbon isotope ratio values can be used as additional evidence to identify significant geological events such as mass extinctions or volcanic eruptions. Additionally, carbon-12 and 13 isotope ratios can be used to trace processes that transformed a soft sediment into a rock and altered it. Studying Earth's history reveals that global events impacted ancient environments. Between 125 to 90 million years ago, several oceanic and oxic events occurred. These are periods of time when the oxygen in our oceans has been globally depleted. They occur over a long period of time and are generally denoted by the deposition of dark-colored rocks rich in organic material. These rocks, known as shales, are generally found in deep marine environments where the lack of oxygen at the time of their deposition prevented the decomposition of organic material and instead promoted its preservation. These organic rocks are also characterized by rapid shifts in the carbon isotope composition. In rocks formed in shallow marine environments, like the ones we are looking at now in Government Canyon, such organic rocks cannot be deposited due to the organic material degrading too quickly after it was deposited due to the shallow water. To identify oceanic and oxic events in these environments, we can use shifts in the carbon isotope ratio. OAEs have a unique signature in the ratio between carbon-12 and carbon-13 due to the initial increase in carbon-12 in the environment, often due to volcanic eruptions, and then a shift to a greater amount of carbon-13 as the oceans become more productive. The signature of OAEs in carbon isotope ratios is the same in the carbonate rocks globally. Thanks to this, we can use data from outcrops to approximate the age of sediment deposited through isotope analysis, thus complementing or refining the dating of the rock based on their fossil content, as you learned in the video about biostratigraphy.